At least be something to look at. But boom, now let's see. Let's see if this will work. There we go. I think you're seeing the right thing. All right. Hey, welcome back. Said just a moment ago, if you didn't catch that, is that been traveling a bit, so missed out. Doing some Cisco tests, been kind of busy. Sorry, my apologies. But I can't exactly tell you what inspired this, because there's some confidentiality. But let's just say I got to ask a certain question around the design, and I'm like, oh, please, it's not my employer. So far, I haven't found anything this crazy. We'll get into it in a second. Okay. Usual deal. Hey, I talk about what I know, but they're for illustration purposes only. Vendor isn't paying me to talk about them. They're welcome to, but if they ever do, I'm going to tell you about it. Okay, just to make sure. This doesn't represent any business process for any of my employers, current, past, current, or any clients. And then again, no compensation or inducement from any vendor. Okay, bad design. No, we can use terms like suboptimal to try and soften the blow. But what we're talking about is where design requires some extraordinary workarounds to function efficiently. It's kind of what I'm going to go with. Here we go. What's the purpose? We often inherit designs. So this is about how to fix them. And what a question you should be asking, what makes the most sense? And I talk about this a lot. If you know me personally, is that sometimes I've worked for some big companies, or I work for companies doing a lot of mergers and acquisitions. And so, particularly in some of the industries I've been in, healthcare and in commercial real estate, you acquire some boutique firm, some small practice, and you can be frightened what they did. It makes sense, right? It made sense to them, but if you knew better and if you had some money to spend, you'd never do it, right? So just saying. Okay, triple constraints. You know this because I talk about this every week, right? And it's relevant to these kinds of questions too, like a bad design, right? So I was in a hurry, so I just didn't fix it, right? Oh, I didn't have money to make this thing right, so this is what I was stuck with, right? The quality, and this is about quality or scope. This is a quality idea, right? Here's this thing. Okay, let's do it. This is my example, okay? So I have these 5 routers. There's some more network on the to the left of R1. 2 domains, and assume R1 is in area 0 for OSPF, right? So I have routers 3 and 4 connect to router 2. They're all doing OSPF, but routers 3, 4, 5 are connected using EIGRP, and there may be other stuff on the other side. And router 5 is my problem child. He needs to talk to stuff, and taking a look at this, I'll show you the written directions. R5 needs to get at some networks on the other side of R1. He wants, assume this the Thunderbolt there, that's a T1, and these other are Ethernet links. So good bandwidth. Say, I'm going to call it 100 megs, right? So I want to go using the highest bandwidth. I don't want to go through that T1 link, okay? And I want to have redundancy. So I could do things like, well, I'm just not going to redistribute OSPF on R4, right? I can just, no. But then, okay, so what happens when that Ethernet between R2 and R3 goes down? I'm dead, right? I don't have the redundancy. I have to manually go in and turn redundancy on. Don't want that. And then I find out that there's something messed up on somebody made a change in R2. I don't have access to it anymore, so I can't fix it. Now we're just dead, right? So it's not great. And this question also said can't do a static route. Okay, so this is the mission. R5 needs to access the network hung off R1. We want to use the highest. Sometimes I catch my spelling mistakes a little too late. Okay, we want to have redundancy in case the R2, R3 Ethernet link goes down, and can't use static route. Should have called it D2 just for fun, but okay. So how are we going to do it? All right, the first thought was, okay, I'm going to redistribute OSPF into EIGRP and vice versa, okay? And, taking a look at it, or that does one thing, R5 will have a route that network off R1. It will. The OSPF, and it's going to get it from both R3 and R4. Now, yeah, if it was OSPF on the other side, maybe this would work a little better, because with OSPF and link states, it's one of the disadvantages of ERGRP as a distance vector protocol is it just know R5 just knows about what R4 gives it. So even if there's a better route through R3, well, actually, I don't think it'll make any difference anyway. The problem you have is that R4 has both protocols, right? Okay, so here's what we do. We need to do what options should I do? Do we need to do anything special going from ERGRP to OSPF? And so that's the question, are you going to do E1 or E2 routes? And I was thinking E1 routes because I want OSPF to pick the best link based on the whole path, right? Okay, so I said on under the EIGRP process, redistribute OSPF. On the one with the nice fat link, give it that 100 megabits of bandwidth, small delay, small bandwidth, accurate bandwidth of the metric, right? It's the least metric, so this is probably actually right in a small network. Give it a wickedly bad delay, keep the reliability and load that defaults, right? Not that they're counted anyway, right? So what do these redistribute statements accomplish? For one, okay. So yeah, in the EIGRP domain, if for example I had a second link to R5, I'm going to get the metric for these OSPF routes coming in is going to be much better because of the high bandwidth and low delay. So yeah, it's going to give me a low metric for that the route through R3, but everything's passing through R4. So, and the other question is, do I need to manipulate the metric when I redistribute ERGRP to OSPF? You know, not really, because you think about it, the cost, it's going to pick up the cost from R4, it's going to pick up the cost for that T1, which is high, and coming out of R3, it's going to have a low cost because it's a fast link. So that's going to get me what I need there anyway, especially if I use an E1. If I use the E1 metric, that part of it should work pretty well. But the question is it going to work? And yes or no. So here we go. Needs to access R1. Yes. Want to use I copy this. To use the highest bandwidth. No. Why no? Come back to that in a second. Do we have redundancy? Yes. Because the routes, if the T1 goes down, there's still routes going back to that network off R1 coming through R3. Lots of R's here. Or if R2 or R3 is down, doesn't matter. It's going to take the T1 anyway, and we can't use static routes. And yeah, we're not using static routes. So okay, why no? Well, okay, so the redistributed OSPF has an administrative distance of 170. Now, remember, administrative distance, that's the concept of reliability. So for EIGRP, it gives an administrative distance of 90 for internal EIGRP. So it's learned from inside the EIGRP domain. But if it's an external route, it was redistributed from somewhere else, it gives it the AD of 170. What it does, it helps prevent looping. So that a route comes in, let's go back to the picture. I'm going to scroll back. So if a route comes into R3, it's now an external route. It redistributes that route to R4. It has an administrative distance of 70. So, excuse me, 170. The OSPF administrative distance is 110. So the OSPF native route is going to be authoritative, it won't install that EIGRP redistributed route because it's not in the routing table as an EIGRP route. It won't be redistributed in the OSPF process on R4. Now, what about the stuff coming from R5? Well, that has administrative distance of 90, so both R3 and R4 will redistribute that into OSPF. So then what happens? Okay, so say from R3 knows about the route, it redistributes it, goes to R2. R2 redistributes that route back down to R4. Right, but the 110 administrative distance is worse than the 90 for the local route on R4 direct from R5 using EIGRP. So it'll take that, it'll ignore that OSPF route. It won't think I'm gonna have to shoot across this T1 down the link and create a router loop. It won't do that because of the administrative distance. But the problem is on this whole thing, R4, from R5, I don't want the traffic to then make that right turn on R4 and take the T1. But it's going to do that because its route to that R1 network is coming through OSPF. OSPF has the better administrative distance than a redistributed from R3. So it's going to have an administrative distance of 110 versus 170 for the route coming through R3. So that OSPF route direct on R4 is better than the EIGRP route. So that's where we end up. It doesn't quite do what we want. It does give us redundancy. If the T1 failed, it would take the Ethernet, but it's not doing it first. So, and then this, which is why it's a bad design. This is also why I hate RIP with a passion. If this same thing was RIP on the other side, well, from R4, if it's completely just RIP, it's going to go across the T1 because it goes, well, why do I want to go 2 hops from R3 to R2 rather than going straight to R2 because that's only 1 hop, right? Well, if they were all T1s, that would make sense. But if you had nice Ethernets instead, you want to take the long way, the fast way. It's taking the freeway rather than, it's only like, a mile. Yeah, it's 3 miles on the freeway, but I gotta go through 15 traffic lights or something, right? It's like that. Okay, so there we go. Didn't quite work. Okay, what can I do? I like this one. Okay, how about I move the EIGRP OSPF boundary to R2? So going back to our picture, those bubbles, well, EIGRP now goes all the way out to R2. I could also have said, well, why don't we just make everything OSPF and we'll just skip the trouble? That would be actually the easiest and sort of a no-brainer. But okay, I thought about this one. Here we go. So I add EIGRP 150 to R2, add the redistribute commands to redistribute OSPF and EIGRP, add the appropriate network commands on R2 and R3 R4, update the EIGRP network statements to include the formerly OSPF interspaces, or if you're using commands like IP EIGRP 150 underneath the interface itself to enable it that way instead of a network statement, you can do that too, particularly using named mode. Well, name mode looks a little different, right? You can do that. And then remove the whole OSPF process and all its redistribute commands. Just get rid of it all. Okay, I can do that. Okay, and does it meet all requirements? Okay, so, well, yeah, the routes are getting through because it's all EIGRP. It sees the T1 and gives it a much worse metric than it would for those 2 Ethernet links. So it would go through the highest bandwidths, and of course, that it knows about this other route. Yeah, if you want to have the convergence to be quick, you may have to play around with some metrics so that the well, no, actually, it's so if EIGRP, yeah, I want to play with the metric so that it becomes a feasible successor. So it doesn't have to go, oh, I don't have any feasible successors, and have to go into a query to pick up that T1 route. I can do that, and I didn't use any static routes. So it's there. I might add that extra tweak of like, yeah, I'm gonna try and maybe I'll add some delay onto the link between R2 and R3, so that it makes some metrics, or maybe I use the variance command and expand my retinue of um, how much difference I can include and still have it be a feasible successor. I can do that. It's true. No, but okay, somebody throws this at you and says, no, it's not a company or division, so you can't move that boundary. Okay, so we got to do another guess. Next guess, moving on. Okay. I like this one. Again, this is how physical design, let's talk about the physical design. That's a bad logical design. So it's because that R5 hangs out on its own, yeah, you're stuck with this problem. So logically, one way to do it is, well, I could make it all OSPF, or I can move ERGRP to R2, which is that whole domain then would be contained inside of ERGRP. So R5, rather than having to deal with this problem where the metrics are different, R4 understands then this is not as good a route as the other way. They're all OSPF or all ERGRP. Logically, that's how I can fix this problem. The extra link is how I physically can fix the problem. Because now if I have, and let's do this thing. Okay. So if it's close enough, I can add if they're all in the same room, for example, okay, take some copper, string it up. Good. We're done. Yeah. If they're in different closets, say, can I still run some copper? Do I have some copper running between them? Some structured cabling that I can use. Now, remember, you're going to add some air gaps, right, when you do this. So you'll have to factor that into your distance calculations, right? Remember that you have your 300 meters, but every air gap, every splice, you add distance into that calculation. You reduce your total run based on those gaps. So I added some extra air gaps to this. Okay. If it's fiber, can I use fiber again? The additional air gaps have to be factored. Okay, it's all in the EIGRP domain. Therefore, because of those metrics I already built with the redistributes, the metric coming off of R4 into EIGRP looks better going to R3. So R5 would want to go to R3 direct. Obviously, if I lost that link, it's going to go out the inefficient way. So this isn't a perfect solution, I'll give you that. But it's still better. Honestly, I really want to do in something like this where I had multiple links, because assuming something at T1 is going to be some sort of offsite, right? Why would I pay for a T1 inside a building or even inside a campus if I didn't have to? If I can do it, if that's a metro Ethernet, it's different. But like inside a campus, like why would I set up a T1? Just silly, right? Okay, so it does meet our goals. It's not perfect, right? I said there was one case there where it wouldn't work, right? It's a possibility, but okay. But maybe the distance too far. I lack single mode fiber. It's like distance enough. I don't have single mode, or something, right? There's something in there that says, yeah, it's not gonna work. I thought about this one. So take the redistribution, right? And then add this one on R4. Distance, ERGRP 9100. What's that mean? That's going under router ERGRP 150. That's saying for internal routes, the AD is 90, the external routes are 100. So what's this do? Right? Okay. So the ERGRP external routes coming from R3 will look better than the OSPF routes. So the redistributed OSPF is going to look better to me on that router than than the routes coming in from OSPF. So I'll just I'll take the ERGRP over OSPF, right? But that creates its own problem. So now, because they're in the routing table, the redistribute command going the other way into OSPF, which I need if I want to have that redundancy, it's going to redistribute those routes that came in from OSPF back into OSPF. So now it's going to look like I have these routes. Now, with the cost of T1, maybe you just do it and it'll be fine, and because the routes are pretty, the metric's still going to be lousy because of the T1. So it's probably should take the other thing, right? But I think it's still a bad design. It really is. I really think it's a bad design because I really don't want to feed those routes back. I don't want to do that, right? So I said, did I get this right? Yeah. So I went to 4A. I said, well, okay, but I'm going to add some tags, right? So this makes it a little more complicated, right? So to make sure I do this right, I'm redistributing both ways. I'm using that distance command, but I need to make one other thing. So on the OSPF side, I got to create this route map that looks for the tags I put in. So since I'm installing these OSPF, the redistributed OSPF routes on that router, I want to exclude those from redistribution from ERGRP into OSPF. Now they're OSPF interfaces, so they should the OSPF domain should get the type 1 LSAs if they have a designated router that it'll do the DR will still do type 2s for that. I want all that to work because of where that OSPF boundary is. I can't just switch to ERGRP, right? So build this thing. The first part of the route map, that's to say, Matt, when you see that route, that tag, and remember the tags on a route are just, it's a numeric identifier. It has no purpose except what you decide to do with it. So in this case, I'm going to say deny things that have the tag value of 66. The second one that says permit, that without a match statement, that says match everything. So in this case, everything going through there looks at it, says, do I have a tag 66? Great, drop it. Everything else, let it through. So redistributing from ERGRP into OSPF, and I added this piece, the distance on R4. I think I got it. As I put a note, NB nota bene, Latin, right? Good note. I could do more to tailor the metrics. So the routes from R4 would be a feasible, R3 to on R4. I'd have feasible successors. Yeah, sure, fine. Be nice. That would be the trick thing. In a big old hurry, I'd probably go with this. This seems like kind of a quick thing. I notice I'm missing this. I added subnets, and the subnets. If you don't know that one, when you're redistributing into OSPF, it wants to. It'll only take. It wants to take classful. If it doesn't, it doesn't redistribute anything. So you want subnets in there. Okay, so it does everything I want. So happy, right? Annoying question, stupid design, logically stupid, physically stupid. I really don't like putting things off in a corner if I don't have to. There are some things, right? Like I can talk to you about a design that looked like this. Small campus, 2 buildings across the parking lot, fiber attached. The layer 3 is sitting on a chassis on where the router comes in. It's a layer 2 link across the other side, and then there's on the other side there is an SRST router for voice survivability. What I did with that is that not a lot of redundancy, right? It's got two. I did to make it simple, since there's no layer 3 for survivability. The phones, it's on the phone VLAN, 2 links, and I use integrated routing and bridging. So there's a bridge virtual interface to connect it, Okay, so the phones can always get to it. They need to make an outgoing call. They can talk to that router. It's on their subnet. Nobody has to do any routing. They're not lost because they don't have a layer 3 interface to go talk to. They can, as long as they know how to find this guy, that they'll be able to go out and make those calls. The other one is like, well, if it's like a layer 3, the those switches are not layer 3. Great, so the phones can't get to it. Because the failure scenario is going to be where that particular SRSG kicks in versus the one on the converged router for the campus is because that fiber link dropped between the two buildings. So, that's kind of off in a corner, but it makes sense. It's only really going to get used if that thing gets isolated anyway. So I didn't having additional redundancy. It's sort of, well, okay, if something happens with the whole campus, can the other phones get to there? I don't know what the phone guys did with it. Layer 3's up, yeah, they should be able to do it, but okay. So what if I could use a static route? Okay, so I'm going to assume we can summarize, in which, again, this is the design thing. Did I build this in a way that makes enough sense that I can actually summarize my routes? Because I want to make this as simple as I can. I don't want to have to install like 15 routes. If I've got, I said 10.10.00/16, right? That's what I assumed. And so I put in this default route. Okay, and here's the, this would have to be done on R4. And that next hop, 192.168.255.2, I'm going to assume that's R3's interface going back to R4 direct. So I can do this. Here's a static route. Just do it. Does it meet my requirements? And I had to say we're going to skip the static route thing. Okay, needs to get to R1. Well, yeah, because R3 has a route. So if I install the static route, push the traffic to R3, it can come out again. I've got to do a little more to keep from doing asynchronous routes, which I didn't really discuss there. I could, and there's some thinking behind that. Although, frankly, on the OSPF side, I'm not so worried about it because the metric should be high going across the T1. So if I do the metric, I just need to do the metrics right to make sure R3 looks like a better route than R4, right? So I'm using the highest bandwidth. Okay, do I have redundancy? Well, no, because the static route, okay, that goes down. Well, if the R2, R3 goes down, there's nothing in there that's going to make it not work. It's still, if as long as R3 is still working, it's like, you get this traffic. Boom, go, right? Not good. Okay, not perfect. So I said 5A, okay, and do some add some tracking. So IPSLA, here's, I assume that was going to be the interface on R2, or I said is loopback for R2, and push it out the interface, which I'm going to assume is the one from R4, R3 to R4. Have it check every 10 seconds. Probably I should do it more, really, but every 10 seconds. Run it forever. Track reachability. Here's this route, track 5. So the idea is if the track fails, take the static route out. It's not bad. Again, asynchronous, need to probably want to make sure my thinking is right. I would most likely create the scenario in the lab. Even with the simulator, it should work. As long as I have all the right interface bandwidths, right? Delays on the ERGRP side will be a little off, but simple lab, I can do it. I can check it. Am I right? So, okay, it needs access 1. Sure, it does. It has a route. we want to use the highest bandwidth. Yes, we do. Redundancy, yes. I still think it's a bad design. And the reason I think it's a bad design is that, I've had to create this whole monstrosity, right? So I've got this SLA running just to test it. I need to verify. I want to test this thing carefully to make sure that, okay, so I said source interface, blah, just to make sure that I definitely try some other scenarios to make sure it doesn't track some other way and think it's up when it's not. So, yeah, I mean, I do this. I can actually think of some scenarios where I do something like this, but and that the times I would do it would be something like, I sometimes describe a network as an ellipse. So you have two hub nodes, and everything connects to the two hub nodes, and you're not doing active-active. You're doing kind of as primary and secondary. So primary weight, EIGRP, you can play with delay on the secondary, or you can use offset lists to control primary and secondary. But the secondary node it's not load balancing. It's connected but not doing much. I can see if those are two data centers, say two different data centers where these hubs are, that secondary data center, maybe I have a resource so I needed to run like some backup traffic. To the backup is running in the secondary data center. Maybe I do route maps where I specifically say, hey, this traffic uses a route map to go over to the secondary data center, and I have to do symmetric route maps, and it can get complicated. Depending on how many layer 3 levels, how much do I have to push? How much do I have to pry that traffic away from the route? It's that salmon from running upstream, right? How far do I have to pry it out to get it going where I want it to go? How many route maps do I have to build? It's a thought. And then how much testing do I have to do? How many of these kind of track statements do I have to do to make sure that, hey, that secondary link went down, you need to go take the other link. I don't want to fail the traffic. I want it to be able to run its backups. Right? So, there are the right scenarios for these, but something particularly this simple, it's like, oh, please, don't make me do this. Okay. And why this exercise at all? One, this is also me working through this scenario in case I see it again. Hint, hint. So a lot of times we have to do all these heroics in software to make up for bad physical and logical designs. And the second line where I say keep the what ifs to a minimum. If I've built the thing well, it should be pretty stable on its own. So, for example, where I move the EIGRP OSPF boundary, it should be pretty bulletproof. R5 is going to fail because the link between R5 and R5 and R4 goes down, so it's isolated. Okay, sure, right. If I lose the link between R3 and R4, well, actually, it's not that bad. It's got a route. It'll work. It'll work both directions. And the route for R5 is not going to be advertised by R3 anymore because it doesn't have a connection to it. And because particularly if it's a physical link failure, well, that's really immediate, right? Anything I learned through the down physical link, I send a poison out. I poison that route. It drops out. R2 doesn't even know anymore about those routes through R3. So the more I can make this so it's idiot-proof, I'm much happier. I started to do tags and route maps, the rest of it, I'm like, yeah, I got to have a really good reason. That's how I think. Make this as simple as possible. Keep it simple, right? Okay, here's your homework. You have to do designs like this. Stuff you inherited, right? Oh, that building's that way for years. Oh my God, man. I don't know. Again, just like when my first talks on redundancy, you can't fix everything. Sometimes there's just no way out of it. But we have this stuff, start making the plans to fix them. And somebody's going, well, I don't, I'm busy enough. I don't want to have to go out and do yeah, but there's going to be a reason, right? So say end of life um, is coming up for like some of those routers, R3, R4, R5s. One or more of those is going to be replaced. Well, while I'm doing that, can I string up the second link? Um, can I move the OSPF, moving the software-wise, moving the OSPF EIGRP boundary, if or moving it the other way and just getting rid of EIGRP is what direction we're going as a company. Oh, okay, make sure that gets addressed. We're gonna do a conversion. We're moving everything to EIGRP. Great. While we're doing that, that's one of the first ones I want to fix. So I can get rid of that stupid problem and clean up the config, make it simple. Because I'll tell you what happens. Whoever end of life or it breaks and maybe they don't have couldn't get the backup, so they're kind of reassembling the config for R4 on the fly. Yeah, they miss all those route maps and distance statements and the rest of it, and they kind of do what makes sense, and then it's not working right. So that's why you're going to start making plans now. And there's a lot of the stuff, like really, it can be not much more in the back of a napkin drawing until you have to pull it out. But I'll tell you on a server thing, right? Um, had some end of life stuff, was working through it. I was building that stuff. This was a long time ago. I was building this stuff as quickly as I could. Why? Because we had all these dog old servers, old, bit flaky, bit worried, and I had I can't think of the name of the product anymore. It's one of these sync softwares running. So it was syncing directories between the old one. I'd already started to build that. So I was well along the process of doing this. And this particular server just started to flake like mad. And okay, what made it worse was this software we were running. It it was a thick client, but it did something I thought was just monstrously stupid. So you'd run this installer, and it would use a map drive for the path to the executable, but the DLLs that use the UNC path, that use the full server name. So I either had to go around to every user, we had to redeploy the entire application to all the users to just pick this up, move it to a different server, or we had to take the new server that's coming online, do a rename. So get all the files copied over, rename the one, rename the other, or rename the flaky one, rename the other one to this name, do what needs to get done to finish it, right? I was able to get all that done overnight. So yeah, we had problems. We did for critical employees. We reinstalled it, had bad UNCs. We put it in a temporary spot, remap drives. It worked out, but it was just painful, right? I already knew where I was going. I was a long way in the process. We were going to do a lot more, validation and testing and certification before we brought online. But of course, events took us. So you got designs like this. Find them. Start making your plans. That's my direction for you today. Go forth and conquer, kiddos. Okay. Thanks for watching. This is a short one, especially for me. I love talking. I talk to the dog. You can subscribe to my YouTube channel. Yes, that's a lousy URL. If I get enough subscribers, they're going to let me fix it and do a better URL. In the meantime, you can clip this and then copy and paste. Or if you find me on Facebook, LinkedIn, Twitter, you should, particularly Facebook and LinkedIn, I have direct links in there, so you can just straight to it. Okay. follow me on any of these. I always say Facebook. You can follow me. I don't friend if I don't know you or I don't have some other real close connection. Just I see these things like some session is from Nigeria, and I'm like, I know it's kind of prejudice, but given every email you seem to get that says I have $50 million, and if you just send me like $50,000, I'll give you the rest of the money. Yeah, don't I wish? Yeah, no. So it just makes me nervous when I see these. And, people send me some friend requests, and it's like the entire profile is like 3 pictures. There's no content. So I'm like, no. Anyway, follow me on these things. Friend me on LinkedIn, something. Anyway, hope this was fun, entertaining, useful, something, whatever. That and then we're gonna go psycho picture. You leave comments in the comments, topic suggestions, the rest. I started working on one. I want to actually do something a little basic and go for the OSI model soon, just to, if you're studying for like the CCNA or the CCENT, just sort of another look at it, another try to get it right. I know when I first took my CCNA a lifetime ago, when there was only the CCNA and not CCENT, that I struggled a bit with it because I was green as grass. I was pretty new in this field, so thought I'd kind of add that into the great beyond. Yeah. Have a good night, and I hope to see you next week. Thanks for joining.